In this video, we'll continue Chapter 3, Matter and Energy, by discussing temperature. Temperature is a measure of heat energy. In this section, we'll convert temperatures from one temperature scale to another. Temperature is a measure of how hot or cold an object is compared to another object. It can be measured directly using a thermometer. Here is an example of thermometer with two different temperature scales. We have the Celsius scale on the left and the Fahrenheit scale on the right. If we're measuring body temperature, the normal range would be 36 to 38 degrees C or 96.8 to 100.4 degrees Fahrenheit. If you're lower than the normal range, you would have hypothermia. Higher than the normal range and less than, let's say 105.8 or 41 degrees C, you have hyperthermia, and above that temperature, you would probably experience death. The two most common temperature scales are Fahrenheit, or degree F, and Celsius, or degree C. The temperature difference between boiling and freezing of water is divided into smaller units called degrees on these scales. On the Celsius scale, there are 100 degrees between the boiling and freezing points of water. On the Fahrenheit scale, there are 180 degrees between the boiling and freezing points of water. Scientists have discovered that the coldest temperature possible is negative 273 degrees C. On the Kelvin scale, this is called absolute zero and is represented as 0 Kelvin. The Kelvin scale has units called kelvins. There's no degree symbol in front of the K to represent temperature. There are no negative temperatures on the Kelvin scale because 0 is the lowest temperature possible. It has the same size units as Celsius, so one change in Kelvin is the same as 1 degree unit change in Celsius. Here's a comparison of the temperature scales, Fahrenheit, Celsius, and Kelvin, between the freezing and boiling points of water. We see the freezing point of water at the bottom here as 0 Celsius and 32 degrees Fahrenheit. That is 273 kelvins. Normal body temperature would be 98.6 Fahrenheit, 37.0 degrees Celsius, and 310 kelvins. The boiling point of water is 212 degrees Fahrenheit, 100 degrees Celsius, and 373 kelvins. Let's have a learning check. What is the temperature at which water freezes? 0 degrees Fahrenheit, 0 degrees Celsius, or 0 Kelvin. What is the temperature at which water boils? 100 Fahrenheit, 32 Fahrenheit, or 373 Kelvin. How many Celsius units are between the boiling and freezing points of water? 100, 180, or 273. Here we see the temperature at which water freezes is 0 degrees C. What is the temperature at which water boils? 373 kelvins. How many Celsius units are between the boiling and freezing points of water? There are 100. Given a temperature in one scale, we may need to convert to another scale. To convert temperatures between Celsius and Fahrenheit, we need to adjust for the size of the degrees. There are 100 degrees Celsius between the freezing and boiling points of water, and 180 degrees Fahrenheit between the freezing and boiling points of water. We can derive a formula to convert between these temperature scales. The temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. This changes degrees Celsius to degrees Fahrenheit. Okay. The temperature in degrees Celsius can be calculated as temperature in Fahrenheit minus 32 divided by 1.8. This changes Fahrenheit temperature to Celsius temperature. These are the two formulas that we'll use to change between these two temperature scales. Let's solve a temperature problem. A person with hypothermia has a body temperature of 34.8 degrees C. What is the temperature in degrees Fahrenheit? We need to analyze the problem and decide what we need to do. We're given 34.8 degrees C. We need to find the temperature in Fahrenheit. We'll use the temperature equation. The temperature in Fahrenheit is equal to 1.8 times the temperature in Celsius plus 32. Let's plug in our value of 34.8. We're going to plug that in for the degrees Celsius. The temperature in Fahrenheit is equal to 1.8 times 34.8 plus 32. So the temperature in Fahrenheit is equal to 62.6 plus 32, which is 94.6 degrees Fahrenheit. Since we have three significant figures in our original number, then we're going to have three significant figures resulting from that number in our final answer, because the 1.8 is an exact number and the 32 is an exact number. So we'll express our answer to the tenths place. Here's a temperature comparison chart. We'll just look at a few values. The sun is 9,937 degrees Fahrenheit, 5,503 degrees Celsius, and 5,776 kelvins. Water boils at 212 degrees Fahrenheit, 100 degrees Celsius, and 373 kelvins. Room temperature, for example, is 70 degrees Fahrenheit, 21 degrees Celsius, and 294 kelvins. Nitrogen liquefies at negative 346 degrees Fahrenheit, negative 210 degrees Celsius, or 63 kelvins. Absolute zero is 0 kelvins, negative 273 Celsius, and negative 459 Fahrenheit. On a cold winter day, the temperature is negative 15 Fahrenheit. What is the temperature in degrees Celsius? Here's the formula for converting Fahrenheit to Celsius. So we just need to plug our value in for the T sub F. So the temperature in degrees C is equal to negative 15 degrees Fahrenheit minus 32 over 1.8. So that's equal to negative 47 divided by 1.8, which brings us negative 26.1 degrees C. We see that on the top in the numerator, we don't have any decimal places. Our 32 is exact, but the 15 has no decimal places, and therefore our final answer should also not have any decimal places, and we should report it to the ones place, which leaves us with 26 degrees C for the correct answer with the correct number of significant figures. What is the normal body temperature, 37 degrees C, converted to kelvins? The temperature in Kelvin is equal to the temperature in degrees C plus 273. So that's equal to 37 plus 273, which is equal to 310 kelvins. Now, in some books, or perhaps in your online resource, you may see this number for conversion, 273.15. So if you have more significant figures in the given value, you may need to use this more precise conversion factor for the difference between Celsius and Kelvin, 273.15.